and the most convincing evidence for parallel universes uncovered. Hook. What if every choice you've ever made, every path you didn't take, didn't just vanish into the land of what-ifs? What if those alternate realities are playing out right now in a universe hidden from our own? Or get this, astronomers are looking back to the very dawn of time, and the patterns they're seeing in ancient cosmic light hint that our whole universe might just be one bubble in a giant cosmic ocean. And no, this isn't just some sci-fi movie plot. This is actually a frontier of modern physics. Introduction. Parallel universes, the multiverse. Sounds like something straight out of a comic book, right? And yeah, for a long time that's pretty much where the idea lived. But now, some of the smartest scientists out there are seriously looking into clues buried in the very fabric of reality that suggest our universe isn't alone. Now, these aren't definitive proofs. Not yet anyway. Instead, they're more like tantalizing hints, predictions from theories and some really strange cosmic oddities that are making us rethink everything we thought we knew. We're going to explore these incredible clues and the mind-bending theories that suggest our reality is just one slice of a possibly infinite pie. So, what's the deal with this evidence? Where are these clues hiding? Let's get into it. Section 1. The Quantum Multiverse. Many worlds, infinite possibilities. First up, we're diving into the truly bizarre world of quantum mechanics. This is the theory that describes how things work at the tiniest scales. Think atoms and particles. Down at this level, stuff happens that just doesn't make sense based on our everyday experience. One of the weirdest things about it is something called superposition. Basically, a tiny particle, like an electron, isn't in just one specific state until you actually measure it. Instead, it's kind of in a blur of all its possible states at once. Imagine flipping a coin. While it's spinning in the air, it's neither heads nor tails, right? It's only when it lands and you look at it that it settles on one. So what happens when you do make that measurement? That's the million-dollar question, known as the measurement problem. And one of the most mind-bending but also kinda elegant answers is the many worlds interpretation, or MWI for short. Hugh Everett came up with this back in 1957. The MWI pretty much says, let's take the math of quantum mechanics literally. What it suggests is that when a quantum measurement happens, reality doesn't just settle on one outcome. Nope. The entire universe supposedly splits, creating a brand new parallel universe for every single possible outcome. So in one universe, the electron is here. In another, it's over there. That spinning coin we talked about? In one universe, it lands heads. In another, almost identical universe, it lands tails. This branching happens all the time with every tiny quantum event, leading to this mind-bogglingly huge, maybe infinite, number of parallel universes. Each one has a slightly different history, a different version of how things played out. Did you have coffee this morning? Well, according to this, in another universe, another you had tea, and that tiny choice split off a whole new branch of reality. Now, it's really important to remember that the many worlds interpretation is just that, an interpretation. There's no direct, slam-dunk experimental proof that these other worlds are real, or a way to tell for sure if MWI is right over other ideas. But it's a neat solution because it sidesteps some tricky problems in other quantum interpretations, like the whole mystery of the wave function collapse. For scientists who are big fans, like physicist David Deutsch, MWI isn't just some handy math trick. They think it's literally how reality works. Deutsch and others have even put forward the idea that future quantum computers, with all their power, could actually give us some indirect evidence for MWI. These super-fast computers work by using superposition, basically exploring tons of possibilities all at the same time. Some theorists think this parallel processing is literally happening across many different worlds, with the computer tapping into the resources of these parallel universes to get its incredible speed. Google's recent breakthroughs with quantum chips, like their Willow chip, have kicked this debate back into high gear. Some folks, like Google's Hartmut Neven, have suggested their performance lines up with MWI. But critics are quick to point out there are other ways to explain it. and we still don't have solid proof of parallel universes. So the debate's definitely still raging. But the many worlds interpretation? It's still a deeply thought-provoking idea that comes from taking quantum mechanics seriously. It paints this picture of a multiverse absolutely bursting with every possibility you can imagine. Section 2. Echoes of Creation, Cosmic Inflation and Bubble Universes. All right, let's pull way back now, from the tiny quantum world to the enormous scale of the entire cosmos. Our universe, as we know it, kicked off about 13.8 billion years ago in what we call the Big Bang. But the classic Big Bang theory had a few head-scratchers. Like, why is the universe so incredibly even in temperature over huge distances, even in spots that couldn't have talked to each other in the early days? That's called the horizon problem. And why is space itself so geometrically flat? That's the flatness problem. The theory of cosmic inflation, cooked up in the 80s by physicists like Alan Guth and André Linde, offers a really powerful answer. It suggests that in the very first blink of an eye after the Big Bang, we're talking an unbelievably tiny fraction of a second, the universe went through this crazy fast exponential growth spurt, expanding way faster than light speed. This massive stretch would have ironed out any early wrinkles and curves, which explains why it looks so flat and uniform today. Inflation is a big deal in modern cosmology because its predictions, like the specific patterns of tiny temperature wiggles in the cosmic microwave background, that's the Big Bang's afterglow, have been stunningly backed up by observations from satellites like WMAP and Planck. Now here's where it gets really juicy for parallel universes. See, most models of inflation don't just stop at one big bang-up expansion. They often lead to something called eternal inflation. In this picture, inflation might have stopped in our little corner of space, letting our universe cool down and form stars and galaxies, but it's still raging on in other regions, way beyond what we can see. These eternally inflating zones could be constantly churning out countless bubble universes, each one potentially way bigger than our own observable universe. Our universe? It would just be one bubble in this enormous, ever-expanding multiverse, like a cosmic foam made of countless other universes. And get this, each one could have its own unique laws of physics, different fundamental constants, or even a different number of dimensions. This isn't just some wild guess. It's what many well-thought-out inflation models naturally predict. If inflation really happened, and the evidence is pretty solid, then a multiverse might just be part of the deal. Scientists have even hunted for subtle clues of these other bubble universes, like weird distortions or bruises in that cosmic microwave background we talked about. These could be scars from a collision between our bubble universe and another one, way back when. So far, no smoking gun for a cosmic fender bender has turned up. Most of the potential signals are either too faint to be sure, or could be explained by things like cosmic dust. But the theoretical connection between inflation, which is pretty well backed, and the idea of a multiverse is still a really compelling argument. Section 3. The Fabric of Reality, String Theory and Hidden Dimensions. Next up, we're venturing into the super advanced cutting-edge world of string theory. For ages, physicists have been chasing the dream of a theory of everything. That's one single framework that could finally marry Einstein's theory of general relativity, how gravity and the big stuff in the universe works, with quantum mechanics, the rules for the tiny stuff. And string theory? It's one of the top contenders. Basically, string theory says that the most fundamental building blocks of everything aren't little points, but tiny, vibrating, one-dimensional strings. Just like a violin string vibrating in different ways makes different musical notes, these tiny strings vibrating in different ways give us all the different particles and forces we see. It's this incredibly neat mathematical setup that seems to smooth out a lot of the bumps between general relativity and quantum mechanics. But one of the wildest things string theory predicts is more spatial dimensions than the three we know: length, width, height, plus time. These extra dimensions are thought to be compactified, basically curled up so incredibly tiny, maybe around the size of the Planck length, which is unimaginably small, like 10 to the negative 35th power meters. that we just don't notice them. And this is where parallel universes pop up again, through ideas like brain worlds. In some flavors of string theory, especially M theory, which includes strings and these higher dimensional things called brains, short for membranes, our entire three-dimensional universe might be like a giant sheet, or brain, floating in a higher dimensional space called the bulk. And if our universe is one of these brains, well, why couldn't there be other brains, other universes floating right alongside ours in this higher dimensional space? These other brain worlds could be just a tiny smidge away from us in these extra dimensions, but we'd never know it. We, and most of the forces we experience, are basically stuck to our own brain. Gravity, though, might be special. Some theories say it could leak between these brains. If that's true, it could lead to effects we might be able to spot, though we haven't found anything definite yet. Some really out there theories, like the ekpyrotic model, even suggest that our Big Bang itself was caused by two of these brains colliding. Now, string theory is super compelling mathematically, and some recent theoretical work even hints it might be the way to unify physics. But here's the catch. It doesn't have direct experimental proof yet. The energies you'd need to test it are massive, or the scales are just too tiny. That said, there are some very fresh studies, not peer-reviewed yet, so take them with a grain of salt, suggesting that certain things we see in the cosmos, like how dark energy seems to be changing, might actually be the first tiny hints of observational support for string theory. If string theory, or something similar, ends up being the right way to describe reality, then extra dimensions and possibly these other brain worlds or parallel universes suddenly become a very real possibility. Section 4. Whispers in the Static. Cosmic Microwave Background Anomalies. Let's talk about the Cosmic Microwave Background, the CMB. Think of it as the faint leftover heat from the Big Bang, a snapshot from when the universe was just about 380,000 years old. It's pretty much a baby picture of the universe. And it's incredibly smooth, temperature-wise, sitting at about 2.7 Kelvin. But if you look closely, there are tiny temperature variations. Scientists call them anisotropies. These little blips were the seeds that eventually grew into all the big stuff we see today, like galaxies and clusters of galaxies. Scientists have mapped this CMB with incredible detail using missions like COBE, WMAP, and the Planck satellite. And while our standard model of cosmology, the one that includes inflation, does a fantastic job explaining most of what we see in the CMB, there are a few weird anomalies, unexpected patterns or features that don't quite fit the simplest picture. We're talking about things like an unusually large cold spot, a patch that's significantly colder than the areas around it, some strange alignments of patterns on really big scales, sometimes cheekily called the axis of evil, and other subtle oddities. So, could any of these anomalies be clues pointing to something beyond our standard understanding? Maybe even evidence of bumping into other universes? Some scientists have definitely wondered about that. For instance, that CMB cold spot. Some initially suggested it could be a sign of a collision with another bubble universe, or maybe the gravitational tug from a giant structure in a nearby universe. Back in 2015, Caltech cosmologist Dr. Ranga Ramchari found an unusual signal in CMB data. He cautiously suggested it could be interpreted as stuff from a neighboring universe leaking into ours. But he and other scientists were quick to say there was a good chance it was just noise, or something more ordinary like dust in our own galaxy getting in the way. It's super important to stress that these ideas are very speculative. Most of these CMB quirks can often be chalked up to more boring things, like issues with the instruments, dust in our galaxy messing with the view, or just plain old statistical flukes. You know, rare things that can happen when you have a ton of data. In fact, more digging into the CMB cold spot suggested it might be caused by a supervoid, a huge area with way fewer galaxies than usual. Though even that idea is still debated, with some studies saying a supervoid doesn't quite cut it. Lately, you might have seen some pretty wild claims online about the James Webb Space Telescope, JWST, finding proof of parallel universes, or spotting things from outside our universe. Now, don't get me wrong, JWST is making mind-blowing discoveries about the early universe, ancient galaxies, and the atmospheres of planets around other stars. But the general agreement among scientists right now is that it hasn't found direct proof of parallel universes. A lot of these claims are just misinterpretations of research that's still in progress, or they're talking about super theoretical ideas that haven't been backed up by any solid JWST data. You might see videos talking about odd signals or gravitational leakage supposedly seen by Webb, but these are usually just people speculating or discussing theories, not actual confirmed discoveries of other universes. Even strange neutrino detections from experiments like ANITA in Antarctica have sparked talk about mirror universes where time runs backward, but those are also heavily debated and have other possible explanations within the physics we already know. So even with all the caution and the lack of a smoking gun from CMB anomalies or JWST so far, the hunt is still on. These tiny little deviations from what we expect, they keep cosmologists on their toes, pushing them to make their models better and to think about every possibility, no matter how wild. Section 5. The Convergence of Clues. Why it's compelling. So we've journeyed through the weirdness of quantum foam, zipped across cosmic history, and even tried to peek into hidden dimensions. And as you've probably gathered, there isn't one single undeniable piece of evidence that shouts, "Hey, parallel universes are real." If there was, trust me, it would be the biggest discovery in the history of science, hands down. So why did we call this the most convincing evidence? Well, the convincing part doesn't come from one single smoking gun. It comes from how a bunch of ideas, from totally different and separate areas of physics, seem to be pointing in a similar direction. Think about it. The many worlds idea. That just comes from taking the well-tested math of quantum mechanics and following it to its logical end. The whole idea of cosmic inflation, which explains a lot about our universe and is backed up by those CMB observations, naturally suggests a multiverse of bubble universes. And string theory, a top candidate for a theory of everything, predicts extra dimensions and the chance that these brain worlds exist right next to us. These aren't just random made-up ideas. They're what pops out when we try our hardest to understand reality at its deepest, most fundamental level. And when several different lines of investigation all start hinting at the same, even if it's a mind-blowing direction, scientists definitely sit up and pay attention. Plus, the idea of a multiverse offers some potential answers, though, yes, still hotly debated, to some really deep cosmic puzzles. Take the fine-tuning problem, for example. Why do the basic numbers that govern our universe seem so perfectly set up to allow for complex things, like us, to even exist? Well, if there are countless universes out there, each with different settings for those numbers, then maybe it's not so surprising that we happen to be in one that's just right for life. It's kind of like a cosmic version of the anthropic principle. But, and this is a big but, we absolutely have to keep a healthy dose of skepticism. These theories are way out there, at the very edge of what we know. The evidence we've talked about is mostly indirect and based on theories. Figuring out how to tell these multiverse ideas apart from other explanations, or how to actually test them directly, is a massive challenge. Plenty of physicists are still not convinced, and they're right to demand more solid, testable predictions. That whole debate about quantum computers and MWI, for instance, just shows that even when you get suggestive results, there can be other ways to explain them without needing to bring in other universes. Still, chasing after these big ideas is exactly what pushes science forward. The clues we've found so far are compelling enough to keep researchers busy, inspire new theories, and get people thinking about future experiments that could, just maybe, give us some clearer answers. The whole idea of parallel universes really does stretch your brain and makes you question everything you thought you knew about reality, doesn't it? So, what do you think? Which of these theories or bits of possible evidence do you find the most fascinating, or maybe the most out there? Drop your thoughts in the comments below. We'd genuinely love to hear what you think. And hey, if you're into tackling the biggest, most mind-twisting questions about our universe and what might be beyond it, make sure you hit that subscribe button and ring the notification bell. That way, you won't miss out when we explore something else amazing. Conclusion. Trying to find parallel universes pushes us right to the edge of what science can even comprehend. It takes us to these places where the line between what's theoretically possible and what we can actually observe gets wonderfully fuzzy. While solid, undeniable proof is still playing hard to get, all the clues we've looked at today, from those quantum worlds splitting off, to inflation birthing countless cosmic bubbles, those higher dimensions in string theory, and even those tiny whispers in the early universe, they all come together to paint a pretty tantalizing picture. What they suggest is that our universe, as huge and complicated as it is, might just be one tiny piece of a much, much bigger, unbelievably diverse multiverse. It's an idea that really makes you rethink our place in the grand scheme of things, doesn't it? It forces us to face the possibility that reality is way stranger and bigger than we ever dared to imagine. The science is still unfolding, the debates are lively, and the hunt for answers is definitely still on. One thing's for sure, as we keep exploring these huge questions, we're bound to learn more about the fundamental nature of our own universe. And maybe, just maybe, we'll get a glimpse of others that could be hiding just beyond what we can see. The universe doesn't owe us any explanations, but trying to understand its deepest secrets, that's got to be one of the greatest adventures we humans can undertake.